Hello everyone, and welcome to the A3 webinar series. Today's webinar is entitled Vision Guided Robots. Thanks for joining us today. My name is Clarissa Carvalho, and I'm the Marketing Specialist for the Association for Advancing Automation. I'll be serving as your moderator today. Attendees during this webinar are in listen-only mode, which means that you are muted. If you have questions during the webinar, please submit them by email or in the questions panel at the right of your screen. We will try to address as many questions as we can at the end of the program. If your question is not addressed during this webinar, we will respond via email. The webinar will be recorded and a link will be sent to you in the next 24 hours. For those of you who may be joining us for the first time or after a long while, the Association for Advancing Automation, also known as A3, is the umbrella association for the RIA, AIA, MCMA, and A3 Mexico. These four associations combined represent almost 1,300 automation manufacturers, component suppliers, system integrators, end users, research groups, and consulting firms from throughout the world that are driving automation forward. We are hosting our first virtual conference, AIA Vision Week, taking place May 18th through the 22nd. During this event, we have a whole day scheduled solely around the topic of vision and robots. And since you've joined us today for our Vision Guided Robots webinar, we encourage you to register for the May 22nd Vision and Robot sessions. Participation is free, and anyone interested in these technologies is encouraged to register at visiononline.org. I would like to thank our sponsors of today's webinar. Teledyne E2V is part of the Teledyne Imaging Group. Their innovations lead developments in healthcare, life sciences, space, transportation, defense and security, and industrial markets. Teledyne E2V's unique approach involves listening to the market and application challenges of customers and partnering with them to provide innovative standard, semi-custom, or fully custom imaging solutions, bringing increased value to their systems. With more than 10 years of experience in 3D vision, Teledyne E2V provides a range of solutions from laser triangulation to time of flight, specially tailored for 3D application requirements. Matrox Imaging is an industry-leading supplier of component-level solutions recognized for providing OEMs and integrators with innovative yet cost-effective solutions. Their components include smart cameras, vision controllers, I/O cards, and frame grabbers, all specifically designed to decrease development time and costs while providing optimal price performance within a common software environment. Matrox imaging technology is used by leaders in factory automation, process control, electronics, pharmaceutical production, packaging, semiconductor inspection, automotive manufacturing, robotics, and medical imaging industries. LMI Technologies works to advance quality and productivity with 3D sensor technology. Their award-winning Factory Smart Solutions improve the quality and efficiency of factory production by providing fast, accurate, reliable inspection solutions that leverage smart 3D technologies. Unlike contact-based measurement or 2D vision, LMI Technologies products remove complexity and dramatically reduce implementation costs while achieving repeatable, highly accurate measurement. Thank you to LMI Technologies, Matrox Imaging, and Teledyne E2V for their sponsorship of today's webinar. I would now like to introduce our presenter for today. Jim Beretta is President of Customer Attraction Industrial Marketing based out of Cambridge, Ontario. He has been an application engineer in automation sales and in corporate marketing for ATS, automation tooling systems, for most of his 16 years in the automation industry. For the last 10 years, Jim has been an independent marketing strategist focused on the automation, robotics, and advanced manufacturing industry. For A3, Jim has been a valuable resource helping plan and deliver webinar content to over 30,000 webinar attendees over the past 5 years. Thanks for being with us today, Jim, and I'll now hand this webinar over to you.
Hi, Clarissa. Thank you so much for the introduction, and welcome to everyone who's registered for this webinar. As you can see from the agenda slide, we're going to be talking about machine vision robotics and some of the opportunities and challenges within the industry. Today's webinar is an expert webinar, and I've invited two industry veterans to give us their perspective on what's happening with them and in the industry, and I'll be introducing them in a few moments. A little warning, if you've not attended an A3 webinar in the last little while, we introduced a new feature, an online real-time poll. I ask the question and you respond, and our poll results are shown real time. We have 2 poll questions, and the next slide is our first poll. We usually find out some interesting information in our polls, and as a marketer, I always find this fascinating, and I'm sure you'll find it interesting as well. So Clarissa, let's launch the first poll. So the question is, how important is machine vision to your automation? So you just click on whatever radio button on the left-hand side works for you. So first one, we're a regulated industry and we absolutely depend on vision. The second one is, hey, it's 80% important. We don't operate well without vision. Maybe next is 50% is important, but it would not shut us down if the vision was down. And the last one is, we're not yet using machine vision, but hope to soon. So if you can click that button, that'll give us a little bit of feedback for this morning's webinar. And I think that distribution is probably about right. I'm always excited to see what people are doing in the industry. So I always usually take a quick picture of it too, so it'll remind me about what's been happening. So we'll go on to introduce our experts for today. And so I wanted to thank the following companies that have allowed their experts to join us in alpha order. Integro Technologies is based in Salisbury, North Carolina. Integro Technologies is a vision integrator and machine vision inspection company providing sophisticated inspection and automation solutions for challenging applications. I also want to welcome Soft Robotics, and they're located in Boston, Massachusetts. They design and manufacture advanced technologies which enable their customers to automate the handling of variable products and processes. Everything with Soft starts with their disruptive gripper design, from their M-Grip adaptable gripper system for pick-and-place applications to Super Pick, a full-stack 3D bin picking solution for both structured and unstructured applications. And I suspect that bin picking automation will be part of the discussion today. So I'd like to introduce our experts. David DeChao is a globally recognized expert in machine vision integration and technologies. He's the principal vision systems architect for Integro Technologies Corp., where he works with sales and engineering teams in the application and evaluation and design of complex turnkey machine vision solutions. Prior to his position at Integro, he was staff engineer for Intelligent Robotics Machine Vision at FANUC, and earlier was the founder, owner, and principal engineer for 2 successful machine vision systems integration companies. David is a recipient of the AIA Automated Imaging Achievement Award, honoring industry leaders for outstanding career contributions in industrial and/or scientific imaging. He's a member of the Automated Imaging Association Board of Directors and serves on the editorial advisory board of the Vision Systems Design magazine. As a key educator within the industry for many years, David has participated in the training of hundreds of engineers as an instructor with the AIA Certified Vision Professional Program. He's well known for his many informative technical articles, webinars, and conference sessions, which span a wide range of machine vision topics and technologies. Carvalho is the CEO of Soft Robotics, Inc. Carl partnered with Dr. George Whitesides of Harvard University in 2013 to explore the commercial applications for groundbreaking soft robotics work pioneered at the Whitesides Research Group in partnership with DARPA. Soft Robotics was formed to commercialize this research in late 2013, and Carl joined as the CEO. Prior to joining Soft Robotics, Carl held a variety of senior positions in global technology companies. Carl holds a BSEE from Virginia Military Institute and an MBA from the London Business School. He began his career as a naval flight officer in the United States Navy, retiring from Naval Reserve in 2013. And we'll bring Carl and David online in just a few moments. So to answer the question about what's happening in vision-guided robots in the webinar today, you'll hear from our experts as they refer to it as VGR, and there's lots happening. In the automation world, there's hardly an automated system that goes out the door without some kind of machine vision application, whether the vision is guiding a robot or not. There's simply lots of reasons for this: traceability, tracking, error-proofing, liability, or just simply the pursuit of quality within manufacturing. vision lights, lenses, and camera manufacturers are innovating, bringing out new products, and improving on classic product lines. They're getting easier to use out of the box, and their support toolkits are world-class. These images today that I placed in the slide give a great overview of what's happening in VGR. From Teledyne's perspective, the camera sensors are spectacular, and they keep getting better. With better sensors on the Matrox imaging side, we're getting better cameras, frame grabbers, and software. And from LMI and their manufacturing 3D sensors, they get better resolutions and are customizing to each application. From innovative companies such as Universal Robots and Robotics out of Montreal, we're seeing that cameras can indeed be easily integrated as plug-and-play devices in a push to make vision easier and to install, especially at the user level, and something I call the appification of automation, where you can use a smartphone, you can likely program a robot, and in this case, a collaborative robot, and the next step, a vision system and a do-it-yourself camera plug-in module. Remember that collaborative robots are still a smaller slice of the entire robot pie. Collaborative robots, though, are seeing a huge growth in popularity and automation, which is great for manufacturing. And this particular robot comes out of the box with built-in vision, not an accessory. And with that, I'd like to bring in the experts for conversation. And first up is Carl with our first question. Carl, welcome to the webinar.
Thanks, Jim. It's great to be here.
Hey, Carl, what is on your customer's mind from kind of the big perspective, like cost, speed, accuracy, or time to market? What are they thinking?
I think the most important thing that we're seeing right now across the board in automation and vision-guided applications is really, it's a mix of addressing labor scarcity, and particularly in packaging and logistics, as well as obviously the ROI. And I think that's one of the things that's exciting about this webinar is I think there's a perception that a lot of vision-guided robotics is complex, expensive, and hard to deploy. And we're seeing applications today where you can deploy with commercially available robots, commercially available vision technology, and get very good ROIs in some of these new emerging applications.
Thank you, Carl. Hey, David, welcome to the webinar as well. What is on your customers' minds for the big picture?
Hi, Jim, and thanks for having me join in this exciting webinar. I think that, of course, I agree completely with Carl, and I think that one of the things that's in the back of customers' minds as they think about, particularly vision-guided robotics, is a little bit of the fear factor, a little bit of the unknown. In that there's maybe a somewhat of a reticence to move forward and implement vision-guided robotics, mostly due to a concern that it's either going to be difficult, or it's going to be, or that they're not going to realize the degree of production that they want to out of that technology. And while I certainly appreciate those concerns, as Carl said also, we see that vision-guided robotics is a very mature technology, something that is quite usable and extremely valuable in providing flexibility and reliability in the automation environment.
Thank you, David. We'll move on to question two. And question two, this is for Carl. So where are your customers investing? Is it hardware? Is it software? Is it technology? Is it training?
I think it's all of the above. We're seeing a huge emergence where vision-guided robotics is anything new. It's just like David said, it's proven. There's great technology out there, but it's really been focused in the classic applications of automotive, machining, inspection. And as the robotics industry is expanding into what we refer to as the general industries market, is we're starting to see huge demand for these applications. And so we're seeing customers who are new to robotics, and so they hear the term vision-guided robotics and they get concerned. And so for many of these customers, it is really understanding what does a full robotic solution look like, where do I need vision-guided robotics, and then how do I bring that technology into my facility. So I think the answer is it's vision, it's robotics, it's software, and it's training. that we're seeing the demand across the board.
Thank you, Carl. David, this same question for you.
Yeah, and I think that in general, expanding on what Carl said, in general, we are seeing we have an expectation, I think, particularly in the times we're dealing with right now, that ultimately the manufacturing sectors, the various industries within the manufacturing sector, will move forward with even more automation than we've seen in the past. Automation is, in this context, is a way to improve productivity, bring productivity back on board quickly, and do it in a way that is autonomous, is reliable, and VGR plays into all of those needs in the industry. And I think we are seeing a move towards more investment, more thought process into moving forward with higher levels of automation in the manufacturing sector.
Thank you, David. I've talked to a lot of people in automation and manufacturing and robotics, and I think we're all talking a little bit about what we think is going to be a resurgence in manufacturing especially in North America. We'll go to question 3, and this one's for Carl. So new technologies versus old technologies. We're talking a lot about what some of these new applications and 2D versus 3D. Who's winning and why?
Who's winning and why? I do want to set it up, and this is something that, Jim, you and David and I had a great conversation about. Is it's my opinion that 80% of the vision guided applications out there today can be solved with existing proven technology, and I think that's really important. And I think it is helping customers and system integrators understand that there shouldn't be this fear. There's great proven technologies out there. And the example I like to use is bin picking. We're hearing a lot about bin picking, and we'll talk more about bin picking today. And many times it's like, oh, bin picking is this new cutting edge area, which is a yes and a no. I mean, we've been doing bin picking of items in manufacturing for decades. It's now bin picking into retail e-commerce that is the new cutting edge area. And so I think understanding, am I bin picking drivetrain components? Am I bin picking unknown items? It's really important. So I think I would answer that. We are seeing continued new demands for cutting edge technologies in the emerging areas such as e-commerce and retail logistics. But at the same time, we're seeing really exciting applications of great proven technology into new verticals. Food packaging is one of them. Primary and secondary food packaging is one where that industry is really taking off with vision guided robotics, but they're using proven technology that is easy to integrate at a good price point. And so I'm excited about, as David said, the existing expansion of VGR into the manufacturing with onshoring and reshoring and advancing supply chains, but then the use of proven technology into these new emerging applications, but at the same time watching the kind of the cutting edge technology into the new applications like order fulfillment.
Yes, it's an exciting time, I think, especially when you're looking at some of the new e-commerce and all the variables that you have there. David, what's your thought on old versus new?
I'll play on that answer a little bit further and give it a couple of maybe different descriptions. I like to think of technology, and I'm a technologist, a hands-on technologist at heart. And I like to think of technology as either being a mature technology in our industry, or an emerging, or as Carl said, cutting edge technology in our industry. And the bottom line is, and I just have to reiterate this, that vision guided robotics is a very mature technology. It can be well implemented and reliably implemented, and it's not that it doesn't require the new and cutting edge technology in order to be successful. and we'll talk about some of this in a bit in some application stories. But the mature technology is still the mainstream technology in machine vision and in machine vision for robotics. And I believe that if we keep that point of view and remember that there are components out there that have been working really well for years and years in these particular use cases, that we're going to have more and more people adopting vision-guided robotics. The new technologies, I think, are the really, really cutting-edge technologies. We see them moving forward a little bit. One of the things I like to caution people about is the idea that we get hype paralysis. I like that term about new technologies, particularly in an industry like robotics and machine vision, where we seem to be, in some cases, a bit paralyzed, waiting for some new technology to come along, when the application and the use case can be completely well solved with an existing technology base. So while there are very nice new technologies evolving, and we watch those, we keep an eye on them as an integration company. We use them actually all the time. But the bottom line is that 80%, as Carl said, and even more perhaps, are very solvable by mature technologies. That doesn't mean they're old. That means they're mature and they're going to be reliable for you.
Thank you, David. My fourth question for the webinar today is kind of a little bit about smarter factories and Industry 4.0 or 4.1 or 5. Is this still relevant when we're talking about vision and vision-guided technologies?
Yeah, absolutely. Thanks, Jim. I think, I love David's phrase, hype paralysis. And I think, when you use the phrase Industry 4.0 and smart factories, I think that drives hype paralysis. And I've been working on a working group to understand the adoption of Industry 4.0 technologies. And what's interesting is there's a lot of very large companies out there who they're like, okay, so I get there's this Industry 4.0 thing, but what does that mean? Instead of just saying, hey, look, we're trying to drive advanced manufacturing technologies, vision-guided robotics, automation, AMRs. And I want to share an actual story. There was an extremely large company. They were saying, we're going to do Industry 4.0 and smart factories. And they had brought into one of their plants, it was a consumer goods company. They brought in one of their plants, a consultancy, to put sensors on all their machines and do IoT. So they were going to put all these sensors on the machines. They were going to put them on Wi-Fi to collect, really, it was temperature data, process data. And consultants came in and said, we can do this. It's Industry 4.0, it's IoT. When they left, a young manufacturing engineer kind of turned to the plant manager and said, everything that they're going to collect of those sensors is in the PLC. And so back to David's comment about mature technologies is, the PLCs that are available today have all this data in it, and you can pull that data. And what they did is they ended up doing it in-house. They just pulled the data out of the PLC, they put it into some simple frameworks, and they were able to reduce their waste by 32%. So I think that's the hype paralysis played out there, instead of saying, what are the great proven technologies out there that can solve this problem. So I think the most important thing when I hear Industry 4.0 and smart factories is really helping the users understand what are the use cases and how can they apply that to them, and just get away from the hype paralysis around the name.
I think there's going to be a lot of people talking about hype paralysis over the next couple of days. David, your turn to answer this about smarter factories and Industry 4.x.
Yes, sure. So just a quick comment, so very brief. I think that in line with what Carl's saying, we get tied up on the terminology, and then we create focus groups to decide how that terminology is going to help us, and the whole process of working with a term that really is something that's been in our industry for forever. Machine vision is a data-driven and a data utilization technology, and data supplying technology. The same thing with robotics. It's a data-connected technology and always has been. And so much of what is talked about in Smart Factories Industry 4.0 is already available in the kinds of systems that that those of us who work in this industry implement all the time. And so don't abandon the ideas of some of those underlying ideas of Smart Factories Industry 4.0 by any means. But it helps to understand that a lot of the technologies that are available to the plant floor right now provide the information, provide the data, provide the archiving that's an integral part of these kinds of concepts.
Yep, that's another good point, right? There's lots of data already floating around there on the floor. You just have to decide where the gap is, right?
Yes.
So we'll go to our next question, question 5, Clarissa. So let's get our crystal balls out. Carl, you're up first for this. What's kind of on the horizon for AGR, kind of near term and far term?
Crystal ball. I think near term is something we've kind of already mentioned. Is I think you're gonna see the expansion of vision guided robotics substantially, and I think that is because they are proven technologies. Their technologies can be integrated today. And as we see automation continue to grow into these new markets, we're going to see vision-guided robotics be very important part of that. Vision-guided inspections, the data analysis that David just mentioned. But I do think at the same time, we're going to continue to see vision being taken to a whole new level. And we're seeing that with what is really the emerging technologies around the more complex vision problems. Doing the image classification, using large data sets to learn, and then make decisions on that through machine vision. So I think continued expansion of the market into great opportunities as we see the robotics industry grow. And then at the same time, I think you'll continue to see fantastic technologies come online to advance the status quo.
Thank you, Carl.
And
David,
I can just add to that.
Yep.
Oh, I'm sorry. Yeah, I just add to that if we look into the near-term future, probably this proliferation of the application-based machine vision and application-based VGR is going to continue to grow and make it easier for people to move forward into this technology. And certainly the other thing that kind of happens here is that robots are advancing technologically, and so is machine vision. And as an enabler, machine vision technology as an enabler for robotics in the realm of vision-guided robotics, those advances in machine vision only serve to advance the use cases and the reliability of VGR overall. And we talk about some of the things like different 3D sensing software for 3D, even 2D imaging, and we don't want to concentrate too much on 3D, but even 2D imaging for VGR that is more cutting edge, like spectral imaging and even thermal imaging. So there's a lot going on, and a lot of it will continue to grow exponentially over the short term.
Thank you, David. We're going to move on now to our next section of the webinar, and I'm going to introduce a couple of these application stories on behalf of LMI. So thanks to Spanny at LMI for this example and the next couple of slides as well. And Kimbele PIMS is an industrial imaging and robot automation company with its main management office and R&D center in Turkey. They make mechatronic applications using advanced software. And this is a body in white application, which involves inspecting unpainted bare metal automotive car bodies for correct door and panel gap and flushness measurements in order to verify critical assembly where tolerances are met. So manual inspection of the car bodies at this stage in the manufacturing process is very difficult because the car body consists of bare metal with sharp and shiny edges that require multiple inspections. And these inspections demand custom filtering and feature multiple tools for completion in a very short cycle time. And in addition, there's a lot of difficulties because in this particular plant, car bodies are manufactured using a mixed model production methodology. That means every car passes on the line is potentially a different model than the previous. So the robot and 3D vision systems must be able to communicate directly with the manufacturing controllers and the key factory systems in order to adapt inline production model changes in real time. And obviously they're using universal robot, collaborative robots. And in this application, GoCater 3D snapshot sensors provide high precision blue LED structured light capability for sensing on shiny edges and surfaces. And we'll go to the next one, Clarissa. And this is it's always kind of nice to show video, even though it sometimes is a little bit choppy. We've got a couple other videos for you. And in this example, Top Eagle is displaying a Blue Wrist EZRG robot guidance solution with LMI Technologies GoCater sensors for windshield locating. And here the GoCater laser line profile sensors are used to locate and measure the gap between the automotive frame and the windshield for proper placement. And in this example, Crum Manufacturing, who's based out of Ohio, the company offers a wide variety of services, including OEM, custom machinery, and robot integration. In this application, carts lined with prefabricated tube cutters must be picked off a shelf and placed into the correct clamshells based on size and shape. The robot system was chosen to do this in order to increase production and to reduce labor content. The challenge is that the robot required a consistent pick point to secure the tube cutters from the cart. The carts, however, are hand assembled, so their size and shapes are variable. And as a result, each row in the cart has a different height and thickness value, causing the tube cutters to sit or to lean in different positions, making it impossible for the robots to successfully pick each one 100% of the time. In this example, the LMI solution included a GoCater 2150 laser profiler, which was mounted to the FANUC robot. And the engineers used a built-in hand-eye calibration to determine the sensor coordinate transformation to the robot coordinates. And this allowed that variable position and orientation of the object directed by the sensors to communicate directly to the robot and for the accurate picking of the tube cutters. And so, David, you're up next for our next application. Oh, I'm sorry, Carl, it's you.
Okay, coming off mute. So really, I wanted to share what is definitely would be an emerging application. This application, it's a 3D bin picking application, but it's apparel returns. And so this customer is an e-commerce customer, and they get unknown returns. They get shipped back to them in these very large cardboard boxes. And then the items have to be picked, singulated, scanned, and returned to inventory. And so there's a couple of vision guided actions here. One is using the Soft Robotics 3D vision system to look into this bin and set pick points. But then you have to identify the items. And so what you'll see is we're using, in this case, Cognex scanners to identify the barcode, and then if the barcode is read correctly, the item is put into inventory. If the barcode is not read, the item is recirculated, and then if it's a damaged barcode, it gets sent to a rework. And so this is an example where you've got a lot of machine vision going on, but you've got the Soft Robotics 3D vision system doing the bin picking of the apparel items in polybags, and then Cognex Vision doing the barcode scanning, identification, and communicating that product to the autonomous warehouse system that this customer uses for storing their inventory. So this would definitely fall under David's classification of an emerging technology into a complex and emerging field of 3D bin picking of apparel.
Very nice. And David, you're up for this slide.
I wanted to start here with just the very basics of vision-guided robotics, and by no means is this is intended to limit the scope of what you can do with vision-guided robotics. Just with simple 2D imaging. This is an example of just a couple of examples in a use case that I would call assembly, sorting, or kitting. The idea of picking multiple pieces for subsequent assembly by the robot, or subsequent sorting or kitting by the robot in other specific applications. The application to the left is connector component assembly, and the robot is being guided by machine vision to pick the small inserts of the connector and then put them into the connector body. You can see in the far right picture the robot picking the insert, and then in the lower right picture towards the bottom, the robot putting it in the connector body. So this kind of assembly is key to many industries, and I hope that you can extrapolate the idea for where it can help in your industries. But what are really the benefits? I think I want to make sure as we talk about applications that we always come back to what is the benefit of this. The benefit is to provide flexible automation that's easy to change over, that handles changes in part presentation, changes in part types, maybe multiple part types, and operates autonomously to do, in this case, assembly, sorting, or kitting, and many other VGR applications in 2D. The application to the right is a Fanuc and Graco application that uses flexible feeders to mix up the parts, mix up a group of parts, either mixed parts or same type of parts, for the machine vision system to be able to singulate those parts and pick them. Another advantage of or another use of flexible feeding like this is the recirculation concept, and that is as those parts come around and get repositioned, they tend to roll onto or move onto their most stable resting state, whatever that may be. That allows the robot to, in 2D even, without 3D imaging, to have a way to pick those parts up repeatably and precisely from a given side, and ultimately all of the parts will eventually get singulated and be able to be picked up. Some of the challenges in these things, tight assembly tolerances, of course, that has to be taken into account. The error stack up comes from not just the vision, but also from the robot. And really, one of the things people forget about a lot is that the stack up tolerance and these kind of things can come from the gripping system, from the gripping technology. And what happens is when we're trying to achieve precision, the vision system and the robot even can be quite precise, but the gripper itself may be, it may be possible, depending on design and depending on the requirements of the application, for the gripper to impart a small amount of error as it moves forward and picks the part up. So all of those things have to be taken care of, have to be accommodated in these kind of applications, but very mature applications, not just in these particular use cases, but in 2D VGR as a whole. And we have, I move on to what I also would call a mature technology, and that is standard 3D bin picking. And when I'm talking about standard 3D bin picking as a maturing technology, I'm talking about applications that have been around, and Carl mentioned this earlier, applications that have been around and successfully implemented for really literally many years, both in 2D, but nowadays more than likely in 3D imaging. So while we're using what is a rather I think for the marketplace, a seemingly new technology. 3D imaging has been around also for many years and has been utilized in these types of application. What is important to note in the 3D technologies, and I'd like to add as we think about 3D machine vision for guidance, is the impact of the software on the success of the application. Imaging systems in 3D or in 2D are designed to produce a successful image, and of course there's some challenge to that depending on the application. But overall, the ultimate success of the application depends on the success of the software to segment, to identify individual parts and to then provide correct locations in robot world space to the robot for a pick operation. And there are plenty of other things on the robotic side to ensure a successful pick, including things like interference avoidance, path planning so that the robot doesn't try to go through one part to pick up another part, and so on. So while there certainly are challenges in 3D picking, homogeneous or non-mixed parts, like we see on the far left and the far right, are actually by far easiest applications, and some parts are good targets, some parts are not good targets. It kind of depends on how much part variation there is, what the nature of the material and the surface quality. Those things and others play a big role. The applications we see in the middle slides are, the middle pictures are heterogeneous or mixed object pick, much harder in 3D bin picking. And here's where I would separate the idea of 3D bin picking in terms of difficulty. We have mature technologies that can do homogeneous parts quite well. The technologies, not just from the 3D imaging side, but from the robotic and the gripping side, in truly heterogeneous mixed objects is still a challenge, and we'll see that. I believe we'll see that growing in the near future.
Carl, you're up for sweet potato sorting.
Yeah, absolutely. And this is a short video. Maybe we'll play it a couple of times, but I want to set up the application. This was an application where, once again, emerging applications, sweet potatoes are hand sorted by size, small and large. That's it. And this was an application where, if Clarissa, you can just run the video again, where the problem was being approached by, how are we going to train the robot to handle these items? How are we going to know this? And we looked at it, and it was something that was literally done, I think, from start to finish. This proof of concept was done in under 2 hours using commercially available mature technology. It was a standard Delta robot arm. It was the integrated navigation software package that the robot company sells, and it's the desktop software. And it was just a matter of really setting it up, doing a 2D blob detect, setting the size threshold that if the blob is bigger than X, it's a whole sweet potato or a large sweet potato. If the blob is larger than this, then it's a small sweet potato. And this was something that once again, the customer thought was going to be much more complicated, and they were looking at very expensive, very complex vision systems that were going to be difficult, and they were thinking about teaching and training. And we were able to just look at it and say, look, this is something that can be done with proven technology off the shelf with very simple programming. And we see a lot of that and are having a lot of those conversations in kind of the new markets, the emerging users of robotics.
Thanks, Carl. That's a good story about paralysis. And David, you're up for this one. What are we seeing?
So I thought that I'd move to conclude these application stories into what I think we truly would want to call an advanced 3D VGR type of application, and that is, as I alluded to earlier, the location and or the segmentation, and then the location of truly randomized parts. Here I'm I'm using some examples from we might call it shipping applications, warehousing, depalletizing, logistics type of applications, and the concept of being able to locate these randomized objects is one that we can achieve in 3D VGR. It's very achievable with some caveats. The thing I think that is most interesting to folks looking at this at first glance is that it seems, and if you see it in live operation, I didn't bring a video, but if you see this in live operation, I think people are quite amazed that the robot and 3D guidance system can go in, move that robot to a wide variety of angular pick points perpendicular to the objects that have to be picked, and successfully grasp those objects. And, while that is, again, something that I would still call an advanced 3DR application, advanced 3D VGR application, one thing I'd like to point out is that sorting or finding and picking these randomized objects in totally random and separated orientations, like you see here, is actually an extremely easy use case. It's on the level of a standard mature machine vision 3D application, maybe even as simple as some of the 2D applications. And so you see a lot of demonstrations of this, and of course I'm showing you some pictures of it as well. You see a lot of demonstrations that look that really have a wow factor, but what we're seeing is by far the most easy 3D mixed part application in this marketplace, in this use case. Where these get really difficult is where the objects can be at unknown heights, unknown orientations, and even mixed, but they are packed adjacent to each other. As in, let's say, a big truck full of boxes, or in a large pallet full of mixed boxes, but the boxes might be very closely spaced and at almost equal heights. That's an application that's been in the works and under research for quite some time, and I've done some myself. It's something that I think will be solved ultimately. And more reliably than it currently is, but it is one of those challenging applications that differentiates two levels, let's say, of advanced 3D VGR, and that is these truly randomized and separated parts versus the heterogeneous, the heterogeneous mixed parts that are tightly packed. Just another consideration, though, and an important note that all of these mature technologies in VGR are ready to go and could be applied. And if you need, of course, further guidance, you can look to your partners and to your manufacturers to see what is going to be best for your particular application.
Thank you, David.
Just a quick word on maybe. Yeah, just a quick word on maybe what's totally new, and I wouldn't say totally new, but things that I think are going to be moving along. We see advances in technology, and I alluded to the fact earlier that the machine vision technology advances and the software advances in machine vision are certainly going to continue to drive new VGR applications. Just a few, and by no means is this an exhaustive list, but 3D sensors that are coming on board due to the proliferation of the Sony DepthSense sensor, 3D cameras in time of flight, certainly advances in laser triangulation, as with our sponsoring partner Teledyne DALSA in the picture below. Certainly, I mentioned earlier the idea of software ease of use. We see additional, and we have a photo from Matrox to the far lower right, much easier configuration of software and calibration for 3D applications. And then some of the more cutting edge, although these things have been around for a while, the marketplace is seeing them as cutting edge. Things like spectral imaging, hyperspectral, multispectral cameras, and even computational imaging, or the combination of multiple images to gain depth images. So all these things are going to continue to drive new applications for VGR, in my opinion.
Thank you, David. We're going to come to our next audience poll. So if you can take a moment and from your perspective, just tell us what's most important to you in vision. And is it system speed? Is it ease of use, uptime, system accuracy, or cost and maintenance? So if you could take a moment and click on the appropriate button, that'll give our viewers and ourselves kind of an idea of what is most important to you in vision applications. I thought as much that most people are always interested in system accuracy. That's really interesting. And of course, ease of use, which is something we're talking about more and more as we move forward. Thank you very much for that, everyone. We're going to move now to some audience questions. I'm going to pass control back to Clarissa.
Thanks, Jim. To our live attendee listeners, please submit any questions you have for David and Carl using the questions panel at the right of your screen. Several questions have already been submitted, and we're only going to be able to answer one or two, but we will get back to you via email. Jim, here is the first question. What are your thoughts on deep learning for vision inspection applications?
I think that's a Carl Voss question, Clarissa. Carl, what are your thoughts on deep vision?
Deep learning for vision. I think this is one that continues with a theme of there's mature technologies and there's emerging technologies. And I think a lot of times people use the words deep learning and artificial intelligence when you really don't need to use those words. And so I think there are applications, as David did a great job talking about structured bin picking, where if I know I'm going to be picking 12 to 18 of the same parts over and over to load a machine, then I create CAD models, I train the vision system, and it runs, and that technology has been available for some time. I think the concept of deep learning is that the robot's going to get smarter over time. And so as once again, David mentioned these completely unstructured heterogeneous bins, they're going to learn and learn. I think the challenge with deep learning is it's still very much academic. It takes a lot of time, and it's very energy intensive. And so I think this is one of those where I would always step back and say, is this once again, to use the phrase hype paralysis, are we using words when really there's great technology that can make this work, or do you really need to go into these emerging deep learning areas?
Thank you, Carl.
Jim, our next and last question is, why is machine vision for VGR difficult to implement?
David, that's for you.
All right. That's a great question, and it kind of is the fundamental underlying theme of our discussion today, in that there is a perception in the marketplace, and I think that's why we see that VGR implementation on robotic arms is still only in the realm of some people say 10, some people say 20% of the total ARM usage overall. And the perception is that machine vision is difficult can be difficult to implement. And I think we've done a good job of kind of describing the separation between difficult and not so difficult. There's no doubt that machine vision requires some technological skills, but so does robotics, and so does programming a PLC. So I think that for those use cases that are low-hanging fruit and not extraordinarily complex in the descriptions we've given you here today, I think that you can be assured that machine vision will not be difficult to use. But there's no doubt that it requires some technological dedication and ease of and understanding to be able to approach any of these applications. I don't I don't disagree at all with the question in the context of some of the more difficult applications. And again, I'd offer to you all that this is something that happens in any kind of automation system. There are things that are easy to design, easy to implement, and there are some that that are a little bit more of a challenge, require a little bit more engineering, a little bit more integration and implementation and technological knowledge. So I don't dispute that does happen in machine vision, but I would just, in answering that question, I don't want to say why it's difficult to use. I would say that it really isn't difficult to use in the application use cases that are the most mainstream. Where it is difficult to use, I think that any good engineer can learn how to apply it. And of course, as I said before, there are great partners out in the marketplace that can help you with the very most challenging applications.
Thank you, David.
Yeah, thank you, David, and thank you, Carl. Due to time, this concludes our short question and answer session, but we will respond via email.
And again, I'd like to thank both Carl and David. And if you'd like, you can take a screen capture or a picture with your smartphone and continue your conversations with directly offline with David or Carl. And please feel free to reach out to each one of them or either one to via email.
Excellent. Thanks, Jim. Thanks, Clarissa. Thanks, Dave.
I want to recognize and thank again our sponsors today. Thanks to LMI Technologies, Matrix Imaging, and Teledyne E2V. Without your kind sponsorship, we cannot deliver to the audience balanced, educational, and interesting webinars such as today's event. There are over 500 engineers, manufacturers, business owners, entrepreneurs, and industrial B2B technology companies from around the world that have registered for this webinar today. This content gets served today and even after this webinar to engineering professionals who can view it all year long. As a webinar sponsor, you get unique access as well as recognition that you're part of the RIA community and a supporter of robotics, robots, and advanced manufacturing with A3. We welcome new sponsors who wish to connect their brand to the A3 and RIA community. So if you're thinking about sponsoring these webinars, please reach out to Clarissa or myself. Our contact information will be on the last slide of today's deck. If you're, and we can go to the next slide.
Yeah, sorry, Jim, there seems to be a little bit of a lag.
That's okay. It's the internet. I'll read my next slide up right now while the system catches up. So if you're involved in sales or marketing in the manufacturing, automation, or the robotics industry, please feel free to join my newsletter where I focus on strategies and tips on marketing and how to find more customers. Just send me an email with the word yes in the subject line to jim@customerattraction.com and I'll subscribe you to our e-newsletter. And if you need help or advice in marketing or branding in the industry, please feel free to get in touch with me at the same email address while we try to figure out how to move to the next slide. And with that, I will pass control back to Clarissa.
Thanks, Jim. Of course, it finally started as soon as you were done. Please join us on Tuesday for our next webinar, How Advances in Grippers and Collaborative Robots Are Solving Automation Challenges. Our Director of Education Strategies, Robert Hushka, will be moderating this exclusive conversation with representation from OnRobot, Sanic, Shunk, and Universal Robots. To learn more about these technologies, use cases, and how you can apply them in your business, register for free on any of our association webinar pages. Lastly, I hope you found this webinar to be interesting and informative. If you have any questions about the Association for Advancing Automation or today's webinar, please reach out to either Jim or myself via the contact information you see on the screen. As a reminder, this webinar has been recorded, and an email with a link to the recording will be sent to you in the next 24 hours. Thank you again to Jim for presenting, David and Carl for being panelists and sharing their time and expertise, Matrix Imaging, Teledyne E2V, and LMI Technologies for their sponsorship, and of course to all of our listeners for your support. Stay safe and healthy and have a wonderful day.